Hello students, this tutorial will lead us through chemical nomenclature. It'll just refresh you on how do we properly name chemical compounds. The main tip I would have is when you are given a chemical formula, we want to first diagnose the correct type of compound that it is. Is it ionic? And then, does it begin with a main group metal or not a main group metal that we'll just call a non-main group? Most of them are transition metals. Is it covalent or is it an acid? Once we have diagnosed this, then we can properly lead into naming, because the names differ slightly based upon these different categorizations. So first, a reminder, ionic is made of metals and nonmetals. Now, the most common compounds that we're going to interact with, if they're ionic, of course, the metal will be written first, because metals can only and will only form cations. And remember, the cation in a chemical formula for our kind of chemistry, inorganic chemistry, that's what we primarily study in AP and in Honors Chem, we write the cation first. So if your compound begins with a metal, it will be ionic. And then if there's at least one other nonmetal, then it'll be ionic. Okay, how do we know if it's main group or non-main group? A reminder, on the periodic table, we know that there is a division line that we just nicknamed the staircase. Any element to the left of the staircase will behave as a metal. We categorize it as metal. And then to the right, non-metal. Now, of course, the exception is hydrogen. That is non-metal all day long. Now, elements that belong to the first column and second column, they always form the same charge, as well as aluminum and gallium. So they got the nickname main group. We never have to question their charge. The transition metals officially belong to the D block of the periodic table. However, the metals, still to the left of the staircase, that start to be found in the P block, well, they also behave as transition metals, even though officially they're not transition. So we can call those non-main group. Now, the lanthanides and the actinides also are non-main group. However, we barely deal with these in chemical compounds because we're not going to be working with these in the lab setting because of their scarcity, but also radioactivity. All right. If your metal, which again, if it's ionic, is we're going to start the compound with it, is found in column 1, column 2, aluminum, gallium, main group. Now, there are 3 exceptions: silver, zinc, and cadmium. Officially, they are transition metals. However, they behave like main group. Silver always, always, always is +1. Zinc and cadmium always, always, always are +2. So they fall into this type of compound. All right, so does it begin with a metal? Then it's ionic. Well, is it a main group or non-main group? And then you'll name from there, and we'll go through some examples in just a moment. So how do we know? So this is ionic, of course, if it begins with a metal. Well, how do we know if it's covalent? Well, that first element is going to be a non-metal. And then the rest will be non-metals. So if it's made of elements on the right side of the periodic table. So for example, carbon dioxide, or N2O5, or sucrose, C12H22O11, all made of nonmetals. It's covalent. Okay, for now, until after Christmas, an acid is categorized as beginning with hydrogen. So if hydrogen is going to be our cation, well then, we may have a metal and a polyatomic ion, but we only need to look at that first element. So that first element, if it is hydrogen, that's the cation in the case, and then we would name it as an acid. Now the only exception is water. we would name that as covalent, but otherwise, acid, acid, acid. So if your first element is hydrogen, we name it as acid. So really, you just look at your first element. If your first element is metal, well, then it's ionic. If your first element is a nonmetal, now we have to be careful because of course hydrogen is a nonmetal, but that's the exception. So if it's beginning with any of these elements, then we're going to name it with the rules of naming covalent compounds, and if it begins with hydrogen, then it's an acid. Okay, so let's get into the specifics then. So if it is ionic but begins with a main group metal, we simply add the cation name to the anion name. Now, we can take the guide of NaCl. That is a great example. Main group metal, column 1, with a nonmetal. So, this officially is the sodium ion, anions. This is not chlorine. Chlorine would be Cl, atom of Cl. I can see that. There we go. Or we also call that chlorine. This is the chlorine atom that has taken on an additional electron to be a -1 charge. So we cannot name it like we do these because this has very, very different properties. So if you remember how we name an anion, a monoatomic, a single atom anion, we drop the ending of the element and replace it with "ide." So that is chloride. So this is the sodium ion and the chloride ion, but we drop the word ion, and this is sodium chloride. What about MgCO3? All right, it begins with a metal, so I know it's ionic. Magnesium, group 2, main group metal. So I just dig right into the naming. This is the magnesium ion, but I do not include the word ion. And this, okay, we need to know our polyatomic ions down cold by name, formula, and charge. That is carbonate. That is its name. That's why you spend time learning them, because the name is the name. We'd have to do any changing to polyatomic ion names other than acids, which we will go through in just a moment. Okay, but in ionic compounds, the name of the polyatomic ion is the name of the ion. Let's just do one more. What if we would begin with, let's say, aluminum and... All right, so begins with a metal and aluminum, main group. I just dig right into the naming. This is the aluminum ion, but I drop the word ion, and this is nitrate. Now, the number of each does not change or get involved or show up in any way in the name. I often have the habit of writing the cation with a capital and the anion with a capital, like a first name and a last name. It doesn't matter. You could write one capital and a lowercase or two lowercase. It does not matter at all. So this could have aluminum nitrate, or this could be a capital and that be a lowercase. Inconsequential. Okay, so that's ionic with main group metal. Well, what if it's a non-main group metal? Okay, well, you have to show the charge of that non-main group or that transition metal. And so Roman numerals are utilized, kind of like a middle name, to indicate what version of that metal cation you are dealing with. So we have to do some interpretation of our formula. For example, CuOH2. All right, begins with a metal. I know it's ionic. Copper, though, okay, it's a non-main group. I look to what it's paired with. I know without hesitation this is hydroxide with a -1. There are 2 hydroxides, so my total negative charge is -2 here. I only have one copper, and I know that copper ion must deliver a positive charge that equals my negative charge if this is a neutral compound. So if I have one copper, that copper must be a positive 2 charge. This is then named copper 2 hydroxide. So we keep the name of the polyatomic ion just like we did with main group. The difference is we have to show what form of copper is being shown here. And we always include Roman numerals. So if it's showing a +1, it's not understood to be there, we have to show that. All right. Be very, very careful because we don't want to group in those elements that belong alongside transition metals but always form the same charge. So for example, ZNO, okay, that's a main group. This is simply zinc oxide. But something like Fe2O3, all right, iron, we have to show the charge of. We know oxygen shows a -2. There are 3 of them. So the total collective negative charge is -6. So I need a +6 to cancel that. There are 2 irons. So each iron must be +3. So 2 +3s will give me a +6 to give a neutral compound. So this is iron 3 oxide. So oxygen, the gin is dropped and you replace the ide. Let's just do one more. What if it would be, tungsten shows some good variety. What if it would be W5S, forgive me, W2S5. All right, well, tungsten, okay, it shows a variety of different charges. So if I go into the formula, I trust that sulfur is going to form a -2 from its position on the periodic table. There are 5 of them. That'll give us a total -10 charge. So I need a +10 to balance. There's 2 tungstens, so each tungsten must be a +5. So tungsten 5 sulfide. And make sure that you get to know your Roman numerals, and we need to show them properly. And it's not just a bar, we need, the top and the bottom. So that's 1, of course, 2, 3, 4, 5, 6, 7. And most commonly, transition metals are going to, usually show us +1, +2, or +3. Okay, so those are ionic, main group, non-main group. What about covalent? Covalent, we know they're going to begin with nonmetals. Not hydrogen, then we would classify it as an acid except for water. So why don't you rely on some examples that you know? CO2, we know this is carbon dioxide. So what is different here are prefixes. With covalent, we don't have to do anything with charges. You examine the subscripts and we will use prefixes to inform about the number of each atom of each element. All right, so what are our prefixes? 1 is mono, 2 is di, 3 is tri, 4, in chemistry, we often use tetra, 5, penta, 6, hexa, 7, hepta, 8, nona. 9, oh, what? I skipped ahead. Sorry about that, ladies and gentlemen. 8 is octa, 9 is nona, and 10 is deca. So we have to get to know these. And I think probably the ones that aren't as familiar would be 4 and then 7. All right, so all we have to do is interpret the formula. Okay, there is one catch. Why aren't we using mono with carbon? Why isn't it monocarbon dioxide? Well, for some reason, we do not use mono on the cation. So do not place the prefix of mono on the cation. However, we do use mono with the anion. So the anion will always get a prefix. The cation gets a prefix except mono. Ugh, so frustrating, huh? But we have to know that. This carbon, we don't use mono with our cation, monoxide. Now, if you wrote monoxide and OO, I am totally fine with that. But we know that there's the no two consonants in a row, but totally fine. Okay, so N2O5 begins with a non-metal, so I just look at my subscripts. The prefix for 2 is di, so di-nitrogen. 5 is penta, and I am fine if you attach the prefix, and even if we have 2 vowels in a row, more than fine. All right, now, something that often we allow ourselves to be caught by. Sometimes we want to improperly call that sulfite. That is not sulfite. This is sulfur trioxide, which does exist. That is sulfite. Remember, a neutral compound, we do not label with charges. Even though we would assign this to be a positive and this to be a negative, if this is existing as an ion, it will be labeled and identified for you. All right, so what about acids? Well, there are actually 2 different types of acids. Okay, if it begins with hydrogen, we know it's an acid. So the question is it a binary acid or is it an oxyacid? All right, we know the prefix bi means 2. To be an acid, it begins with hydrogen. So where is 2 referring to? The number of different elements. A binary acid has hydrogen plus 1 other element. Now you can have more than 1 of each. Okay, so it doesn't mean you only have 1 hydrogen and only 1 of the other elements. Your subscripts can vary, but you only have hydrogen with 1 other element. An oxyacid is hydrogen with a polyatomic ion. And polyatomic ions have at least 2 different elements. So we know then that an oxyacid is going to have at least 3 different elements, and the majority of polyatomic ions contain oxygen, hence the nickname oxyacid. All right, so a binary acid. A binary acid, even though it's only made of 2 elements, actually has 3 parts to its name. We have the prefix of hydro. We have the ending of ic on the anion. And we have the word acid. So, probably the most familiar acid is HCl. 3 parts of our name. Hydro, our anion is chlorine, but we drop that and replace it with ic. So it won't be hydrochlorine or chloride, it will be chloric, and then we add the word acid. So prefix of hydro, ending of ic, word acid. HBr. All right. We need the prefix of hydro. The anion will get an ic ending, bromic, and then acid. Okay, only 2 elements. So we know, beginning with hydrogen, it's an acid. Only 2 elements, so it'll begin with hydro. This is sulfur, but we'll drop the ending. Well, it's really sulfide. Drop the ending, replace it with ic. Hydrosulfic acid. Now, commonly, we may want to call this sulfuric acid. Now, we need the prefix of hydro, so you may call this hydrosulfuric acid. That's okay. That actually is evolved commonly. But we, in constructing the name like this, is truly honoring the steps that we follow. All right, so those are some binary acids. So oxyacid. All right, Well, first, there's no prefix of hydro. No prefix of hydro. You simply look to the polyatomic ion. Now, we only need to know how to name acids that begin with hydrogen, but include the polyatomic ion that end in ate or end in ite. So you look to the polyatomic ion. If your polyatomic ion ends in ate, you change it to ic. If it ends in ite, you change it to us. So I once had a student that said, oh, I know, Mrs. Garrett, how I can remember that ate changes to ic. If you ate an acid, it would be icky. Whatever works. All right, so let's do, for example, HNO3. Begins with hydrogen, I know it's an acid. It's hydrogen combined with a polyatomic ion, so I know it's an oxyacid. All I need to do is look at this polyatomic ion name, and this is nitrate. I know that ate is changed to ic, and then I add the word acid. So this is nitric acid. But what if hydrogen was with NO2? Okay, I know it's an acid. I look to my polyatomic ion. NO2 minus 1 is nitrite. Ite is changed to us. So this is nitrous acid. Okay, what about H2CR2O7? Okay, an acid. I just look to the polyatomic ion. So it doesn't matter the number of hydrogens. Okay, it's an oxyacid because it's hydrogen bonded to a polyatomic ion. Cr2O7 minus 2 is dichromate. But I know that 8 changes to ic. So this is dichromic acid. What about, let's say, HCO2? Well, it is an oxyacid, hydrogen combined with a polyatomic ion. This is carbonite. Ite goes to us. So this would be carbonous acid. Okay, so we've gone through the different types of compounds. We've done examples of each. Now it's just up to you to practice and get really, really good at this. Good luck.